welcome to Jubail Industrial College Fire and Safety Training Centers. We are in hydraulics lab. This is the day 2 for this session, right? In the previous session, we discussed regarding the fire pumps, regarding the operation of the fire pump, various parts, the flow devices, and all. Today, we are going to discuss regarding the sprinkler system, right? So, as for NFPA30, we have 4 different types of the riser. We can see that one, right? We have a dry pipe risers. It's a very common one, right? Used worldwide, more than 80% or 85% in applications. This is a AG risers. This is alternative of the alarm check valve, and we can use the dry pipe valve in case where we don't have problem in the freezing temperature, right? So if there is a chances of the freezing, right, if we have chances for the freezing, we have dry pipe system. We know that water will freeze at temperature above 0 degrees Celsius. So the idea is that, at the top of this valve, which is the dry pipe valve, at the top we have the air or nitrogen under pressure. At the bottom we have the water. So the air just pushes the clapper to keep it in the seated position, and when there is a fire, the sprinkler system will break and the clapper will open, allowing water to go inside the pipe and extinguishes the fire. Then we have deluge valve. The meaning of deluge is flood. So the meaning of deluge is flood, and this used for high hazardous fire, high combustible materials or high fire storage, where we have chances of heat, and the fire growth is so exponential that the normal sprinkler, the closed head will not work. In this sprinklers, in this deluge sprinklers, there is no bulb, so it is always open sprinklers. When there is a fire, the detector will detect the fire and it will activate. It's normally used in the aircraft hangars, chemical warehouses, storage, and where we have highly combustible materials. We have the last one, we call it the pre-axons, right? So the meaning of the pre-axon, that it will take 2 input to activate it. Normally we require this kind of the system in the area where damage from the water is much costly, or and it's not avoidable, like the museum, art gallery, the historical rooms, the old room, where we want to protect everything for long life, the historical parts and all, the books and all, we don't want to destroy that exactly. So if there is a fire, it's getting destroyed, so we want water in those cases when there is actual fire. It will minimize the any kind of the mistake that maybe the sprinkler system broke and water discharges. Because here we have 2 types of the detection. First, a sprinkler system will break, right? This is a double action pre-action system. The sprinkler system will break and allowing the air to release. But at the same time, it needs the detection also. We have a detector. This detector will detect the fire, and they will say yes, there is a fire, and it will send a signal to the fire alarm panel or releasing panel, and those panel will give input to the solenoid valve. Now this is the solenoid valve. This is electrically actuated 24-volt DC solenoid valve. It will open this line. Once this line will open, water will discharge to the drain, and the pressure will be differentiated into the clapper of the deluge valve, and then water will go inside the sprinkler system. So we discussed about wet pipe system, dry pipe system, deluge system, and double action pre-action system. Now we have this is the deluge pipe arrangement along with the foam bladder tank, right? So if we need foam water system, which we need to for aircraft hangars or highly hazardous area where we have stored high quality of the combustible material, the fire will go exponential and water is not enough to fight those fire, maybe class B liquid fire. In those areas we need foam water display system. So this deluge valve will be the same as working principle of the previous deluge valve which I discussed, but here we have a foam tanks. So these foam tanks will allow foam from this line, from this foam proportional mixture, and going to the system to fight the fire. We'll discuss everything in detail. This is just a brief description regarding the GIC fire and safety training center. We have a similar kind of arrangement. You can see this is riser group 2. This is riser group 2. all those valves are the same as the riser group 1, but we have different manufacturer, right? We might be, in some cases we have the manufacturer from the Tyco, in other case we have Viking and Victorian, Viking or Reliable. So we accept more number of participants, and we want to have different number of the risers to allow our lab activity to go smoothly within the time frame defined by the course curriculum. Here we have a fire department connection, right? We know that as for NFPA 13 or NFPA 14, we need fire department connection to supplement the water quantity to those wet pipe system or dry pipe system. So we'll discuss regarding that in detail when we will go to a riser phase. Okay, so we have wet pipe system, dry pipe system, deluge and pre-exhaust system. Now you can see here we have a compressor, right? So this compressor supplying the compressor to the deluge valve, dry pipe system and pre-exhaust system. As I said that above the clapper we have requirement for the air compressor, right? And here we have a nitrogen cylinder. So this cylinder, is like a backup support for those dry pipe system air requirement. In case if the main compressor fail to supply the air requirement to the system, it will activate and to supply the air to the system. Now we discussed regarding the various risers as for NFPA 13. Now we came all the way to the whiteboard, the cutaway board. We can say the cutaway board where we have different kind of the fire sprinkler valves. We mainly want to show our participant the internal parts, right? Because as an inspection, testing and maintenance engineer, once you have enough knowledge to do the various activities regarding those fire protection system, what is the internal parts, how it's working, and what is the maintenance requirement for that. So one who is doing this kind of work, he should be familiar with all those kind of the internal parts. Like here we have mechanical accelerator, flusher switch, dry pipe valve, dry pipe actuator, check valve, gate valve, butterfly valve, foam propulsor, and we can see the sprinklers, piping and couplings, and alarm signal. So we will discuss all in detail one by one. We'll start from this area, then we'll go to the riser wise. Riser 1, wet pipe system, dry, deluge, pre-exhaust, then we'll go to the foam system, and finally we'll go into different ITM tools and techniques we have at our labs. Thank you.